chaps, good morning, Mr. Lesham is here, and we're going to talk about something interesting, not too difficult, but quite interesting. I wrote it last, but we're going to look at convergence and divergence of geometric series, and then for convergent series we're going to learn how to calculate the sum to infinity. I know it sounds completely insane, it's actually quite chill. Okay? So I've written two geometric series, and I want to, with your help, to write a couple more terms for each one of them. Let's start maybe with this. This is a bit easier. 1 plus 2 plus 4. What will be the next term? Remembering it's a geometric one, so we multiply every time by 2. So the 8, and then the next one? 16. Okay, now what happens, let's find out the first S term. So S1 is equal to 1. S2, that means the sum of the first two is 3. S3 is 7. S4 is 15. Let's do one last one. S5 is 31. What happens to the sum as we get the series bigger and bigger and bigger? It increases. And in fact increases bigger and bigger and bigger. If I was to plot these numbers on the graph, what do you reckon it would look like? It's just straight line up? It's going to be like an exponential one, isn't it? It's going to be like this. Look, the step from here to here went up by 2. From here to here went up by 4. Here to here went by 8. It goes up faster and faster and faster. We say that this series diverges. That means it gets bigger and bigger and bigger. Or another one, it could be smaller and smaller and smaller, another minus. Okay, if I had minuses everywhere, it would be just more and more and more negative. Okay? Now you might tell me, hang on, isn't every series diverges? I mean, the more terms I'm adding, it should obviously get bigger and bigger and bigger, right? If I add more, so that should be also get bigger and bigger and bigger, right? You would think so. You're adding more and more and more terms, it should get bigger and bigger and bigger. Let's find out. What's the next term?
1 over 8.
Yeah, okay, it's 1 over 8. What are we multiplying it by? Half. The next one? 1 over 16, and so on, and so on, and so on. Okay, let's do the same thing. You'll need your calculator. I'll need you here, okay? So, S1 is equal to? 1. Starts the same. We'll do it in red. So, trust. S1 is 1. S2 is?
3 over 2.
Okay, we'll do decimals, so it's 3 over 2 or 1.5. Okay? S3?
7 over 4.
And you'll need decimal. Please use a decimal, okay? So we're doing 1.5 plus a quarter. 1.75, correct. Okay, S4. Just add 1.75, add 1 over 8.
1,875.
1,875. Okay, it's still going up, isn't it? It is going up, right? Okay, S5.
You want the next one, sir?
Yeah, add 116 to that.
1,936.
You're reading from the book. Okay, fine.
Awesome.
That's alright. Okay, and then S6. I'm not going to ask you. I can also read from the book. 1,984,375. Now you might tell me, hang on, sir. This is also going up. Yeah, true. But how is this different to that? If this one goes up like that, what would that one look like here?
It's very stiff.
Okay, so if I start like this, how should I go? Should I go straight? Should I go like this? Or show me with your fingers. It's gonna plateau. Good one. It's gonna go like this.
Yeah.
It's starting to going up by less than this. Look, here we went up by 0.5. Here we went up by 0.25. Here we went up by 0.1 something. Here it's not even 0.1. It's 0.005 or something like that. It gets higher, but less and less and less and less. If I carry on to infinity, it's just going to go flat. We're adding smaller and smaller and smaller terms. So I can carry on for another million. It's actually hardly going to move. So we say this series converges. Okay? I don't know if you use that word converge. Converge is like if you got a bunch of, I don't know what, birds flying and they converge, they're meeting in the same place. Okay? Maybe you went on the way and you did your 24-hour solitaire, different places, and then you converge together in the same meeting point. That's converges. Diverges, flies away. Converges, come together. So the question is, and I'm going to ask you, what made this series converge and this series diverges? Every series can either converge or diverge. How can we tell which one will converge and which one diverge without doing all that stuff? I'll leave that for you to think about. Okay, so good answers came here. The key for this answer is to look at this formula. This is the formula to tell you, okay, the nth term. Now the A, the first term was the same, 1 and 1. What was the difference? Is the r's. What would we multiply? Here the r, what did we multiply it by? By 2. R was equal to 2. Here, what did you multiply it by? What is r equal to? No, how do we go from 1 to a half? By half, right? So r was half. When you have r, and this is important, when r is larger than -1 but smaller than 1, the series converges. When it's a fraction, then that's what you said, it's a fraction. What is a fraction? It's the r is a fraction. When r is larger than 1 or smaller than -1, then it's going to be diverge. It will diverge. Okay? Because we're going to multiply by the numbers, not by a fraction. A number larger than 1, it will get bigger and bigger and bigger. Okay? That's when it converges. That is when you're going to diverge. Okay? I will leave you here for a minute. Good. So the first thing we learned is how to identify a convergent series. That r must be between -1 and 1. The next step I can, and they can ask you a question. I just told it to John. I'll repeat. They can give you a sequence. For example, that one: 1 plus half plus 4 quarter plus 1/8. And they ask you, is this a convergent and divergent? Explain your answer. So you need to, first of all, find the nth term. Say, the r is a half. So that's between -1 and 1, convergent. Then they can ask you, look at that. They can ask you, what's the sum at infinity? This is the sum to infinity. Okay? In other words, we added 1/16. 1/32. Carry on, don't stop, all the way. Now, if the series is convergent, that means at some point it's not going to change. When we drew that graph, it's going to just stabilize on some kind of number, and we need to find it. Now it's dead easy to do it. Look at this. What is our formula for n? Remind me what's the formula for n? For Sn, sorry, not for n, for S. Sum of the n term. A times r power n minus 1 over r minus 1, right? Yes. Now actually I'm going to use the other formula because our r is smaller than 1. So 1 minus r to the power n. Okay? Our r is smaller than 1. We can, and listen to this, you can only calculate the sum to infinity when it's convergent. If it's not convergent, if it's divergent, there is no sum to infinity. It'll carry on getting bigger and bigger and bigger. So it's only when we're talking only about convergency. So, let's try and think about it. Okay? I've got A, that's fine, 1 minus r, that's okay. I want to find out what is r to the power of infinity. Now remember, what do you know about r?
R is the difference.
Yeah, but what do you know about r for convergent series? Between -1. So let's say it's positive, just to make things a bit easier, but it's definitely less than 1. Okay? For example, it could be, in this case, it's a half, right? What is a half to the power of infinity? What is a half time a half time a half time a half? Do your calculator, put half time a half, and just carry on. Carry on. See what you get. I'm gonna wait for you. Just experimental maths we did. We saw every time we are time half. Let's say half. Then we time it by half. We get a quarter. We time it by half again. So half power 3 is 1/8. Every time we time by half, it gets smaller and smaller and smaller. When I ask you to do half power 10,000, the calculator just told you 0. It's not 0. It's 0.00. It's 1 down the line. But it gets closer and closer to 0. So half power infinity will be how much?
0.
It will be 0. You'll get closer and closer to 0. So if r to the power of n is 0, then I can write it as a times 1 minus 0 divided by 1 minus r. In other words, what is the s in infinity? A divided by 1 minus r. That's the formula they need to remember. Okay, this was just to show you how I got there from this formula, but ultimately, the sum to infinity of the convergent series, only convergent, you can't work with divergent, is a simple one. It's much simpler than that. Okay? Where did the r power n went? It died. It's 0. Okay? We'll practice it next lesson. Okay? I'll give you some homework now. Cheerio.